You've probably heard this story, right? A philosopher's giving a talk about the universe, and a woman in the audience says, "Nope, the world is on the back of a giant turtle." The philosopher, a bit smug, asks, "Well, what's that turtle standing on?" And she just fires back, "You're very clever, young man, but it's turtles all the way down." And you know what? That kind of perfectly nails a huge problem we have in computer security. We're always trying to protect a secret with another secret, in a stack that just never seems to end.
So to fix this mess, we have to find the bottom turtle, that one single foundational layer of trust that everything else can safely stand on. And for our story today, our hero is this little guy, Zero the turtle. Zero represents that trustworthy base that we're going to build everything on top of.
And that is exactly what we're going to do today. We're on a quest to find that bottom turtle. And we're going to do it by taking a deep dive into two really transformative open source projects, SPIFFE and SPIRE.
All right, here's the game plan. We'll kick things off with the identity crisis that made all of this so necessary in the first place. Then we'll get into the weeds of the SPIFFE standard itself. After that, we'll see how SPIRE, the identity engine, actually brings that standard to life. And finally, we'll wrap up by looking at some advanced architectures and why this is so critical for the future of AI agents. Okay, so first things first, let's set the stage a bit. Why do we even need a whole new way to think about identity? Well, it's because the world we operate in has fundamentally changed. We've gone from these small, trusted networks to a global, completely hostile environment. And this timeline is pretty wild. It shows just how fast that trust disappeared. I mean, think about it. In 1981, the entire internet was a tiny club of just 213 servers, mostly at universities. Everyone kind of knew each other. But by 1988, bam, the Morris worm hits, and suddenly security is a real thing we have to worry about. Fast forward to 2003 with the slammer worm, and we saw that attacks could scale to an insane degree. But the real nail in the coffin was 2014, when Google published their Beyond Corp paper. That was the signal that the old model, the trusted internal network, was officially dead. And this picture, it just says it all, doesn't it? We went from that little high-trust world on the left to the sprawling, global, untrusted internet on the right. The problem is our security models were built for the world on the left, but we're all living in the world on the right. So here's the bottom line, the big takeaway. The perimeter is gone. That old idea of a firewall, a castle wall protecting the good guys inside from the bad guys outside, it's just not realistic anymore. With the cloud, microservices, and remote work, basing trust on where you are on a network is completely, totally broken. And this is exactly where SPFI comes into the picture. If that old foundation has crumbled, we need a new one. SPFI, which stands for the Secure Production Identity Framework for Everyone, is the open standard, the blueprint for defining our new bottom turtle. So how does it all work? Well, you can think of SPIFFE as a universal language for workload identity. It's built on a few key concepts that all work together. You have the SPIFFE ID, the trust domain, the SVID, the workload API, and federation. Together, they create this really robust and complete system.
Okay, at the absolute heart of it all is the SPIFFE ID. It's a simple, structured string, a URI, that gives every single piece of software, what we call a workload, its own unique, unambiguous name. It's basically like a universal passport number for your code. It follows this really clear format, SPIFFE / then a trust domain, and then a specific identifier for the workload itself.
So what's a trust domain? Well, if the SPIFE ID is the passport number, the trust domain is the country that issues the passport. It's the authority that backs it up. It represents a security boundary with a specific root of trust. And this could be your entire company, or maybe just your production environment, or even a single team's department. It's the zone where a set of security keys are considered the ultimate authority. And that brings us to the SVID, the SPIFFE Verifiable Identity Document. This is the actual passport itself. It's a cryptographically signed document that is, and this is key, very short-lived. It could be an X509 certificate for things like mutual TLS or a JWT for authenticating at the application layer. And because these things often rotate automatically, sometimes every hour, the security posture is just incredible. It dramatically shrinks the window of opportunity if a credential ever gets compromised. Okay, so SPIFE is the standard, the blueprint, the what. But how do you actually do all of this? Well, that's where SPIRE comes in. SPIRE is the SPIRE runtime environment. It's the open source engine that takes the standard and puts that turtle in motion. And the architecture is actually pretty elegant.
You have a central SPIRE server, and it acts as the signing authority for your trust domain. Then, on every single machine or node, whether it's a VM or a physical server, you run a SPIRE agent. That agent talks to the server and then exposes a really simple API to all the software running on that node.
Now, this next part. This is where the real magic happens. How does a workload prove it actually deserves the identity it's asking for? It's a two-step process called attestation. First, the SPIRE agent has to prove the identity of the machine it's running on. This is node attestation. It can do this using platform-specific tricks, like querying the AWS metadata API to prove it's a specific EC2 instance. Second, the agent has to verify the identity of the actual software that's calling it. This is workload attestation. It can use things like the process's user ID, a file hash, or a Kubernetes service account. And only after both of those checks pass does the workload get its SVID.
And this slide just perfectly illustrates the whole beautiful automated cycle. An operator registers a policy one time. They say, hey, any workload that looks like this should get that SPIFFE ID. And that's it. From then on, it's completely hands-off. Now, for any of you who have ever dealt with the nightmare of secret sprawl or API key rotation or managing service accounts, this is a total game changer. It's like dial tone identity. It just works. No more manual secrets, no more tickets, and no more risk of some long-lived credentials sitting in a config file for years.
So we have a super solid foundation for a single environment. But let's be real, modern systems are way more complex than that. So let's scale this up and talk about how this works in a whole universe of turtles, especially with the rise of autonomous AI. This is where SPIFFE federation is so critical. Before you have federation, you've got these isolated islands of trust. My production environment can't securely talk to my staging environment, or my company can't connect to a partner's services. Federation builds bridges between these islands. SPIRE servers in different trust domains can securely exchange their public keys, which lets workloads in one domain cryptographically verify identities from another. You get seamless, secure communication across boundaries without ever having to share private keys.
Now let's pivot to the bleeding edge, because this is where things get really, really interesting. Agentic AI. These autonomous agents present a massive identity challenge. I mean, think about it. They're autonomous, they act on their own, they're incredibly ephemeral, spinning up and down in seconds. They're distributed, running across multiple clouds and on-prem systems, and the stakes are sky high. These agents might be managing financial transactions or accessing patient data. How in the world do you secure that?
Well, the answer is SPIFFE. It's almost like it was purpose-built for this exact problem. It gives these AI agents exactly what they need: a strong, platform-agnostic, short-lived, and cryptographically verifiable identity. This is the identity backbone that is going to allow AI agents to operate safely and be held accountable in a zero-trust world.
So, we've come full circle. We started with this seemingly impossible problem of turtles all the way down, and by exploring the really elegant design of SPIFFE and SPIRE, we found our foundation. We found the bottom turtle. And that leaves us with one final thought to chew on. As these AI agents become less like our tools and more like our collaborators, our delegates, how are we going to prove who or what we can actually trust? The answer, I think, has to be built from a foundation just like this one. Thanks for watching.